let us understand what Monte Carlo simulation is all about. Monte Carlo simulation was originally developed by Stanisław Ulam, John von Neumann, and Nicholas Metropolis in the context of the Los Alamos laboratory during the famous Manhattan Project. This project, conducted after World War II, culminated in the development of the hydrogen bomb during the 1940s. The process was initially designed to simulate neutron transport behavior and solve complex problems related to integral calculations. Historically, Monte Carlo simulation was the first powerful algorithm developed for the first existing computer, the ENIAC. From that point onward, Monte Carlo simulation became a powerful tool for science and later for the business world. It essentially consists of a numerical algorithm. By numerical, we mean that it is not analytical. That is, it is not based on formulas or mathematical functions, but rather on the massive use of numbers for generating scenarios and consolidating scientific information. The genius of Ulam in creating this principle lies in the integration of two fundamental concepts. On one hand, the generation of random numbers as a mathematical principle involving the creation of numbers with no predictable sequence. That is what random numbers mean. On the other hand, probability distributions, which describe how values are distributed within a dataset. What this scientist achieved was combining these two concepts together to create Monte Carlo simulation. It was named after the Monte Carlo Casino, a place renowned at that time for generating random numbers through games of chance. So what is Monte Carlo simulation? Fundamentally, Monte Carlo simulation is a process that generates multiple scenarios in turbo mode. Unlike the traditional business approach where 3 scenarios are generated, an optimistic, a most likely, and a pessimistic one, Monte Carlo simulation generates thousands or even millions of scenarios. This allows for the creation of probability curves that offer a more detailed analysis across a continuum, rather than being limited to 3 reference points. This capability has made Monte Carlo simulation an invaluable tool not only in science, but also in business. With over 20 years of experience in the generation, teaching, production, and consulting of Monte Carlo simulation, I have applied this methodology in project risks, financial risks, operational risks, market and liquidity risks in banks and financial institutions, as well as in investment project evaluation, business forecasting, and many other areas. There are at least 3 major myths surrounding this methodology. 1. It is only for PhDs in mathematics, statistics, or physics. This myth stems from the origins of Monte Carlo simulation, which was initially reserved for scientists with advanced training. However, modern techniques have simplified its application, making it accessible, intuitive, and easy to learn for those without a PhD in numerical sciences. Myth number 2, it requires historical data. This misconception comes from basic statistics courses in university, where we were taught that to induce a probability distribution, such as a normal distribution, at least 25 or 30 sample data points were needed to calculate parameters like the mean and the standard deviation. In project settings, we often lack historical data. However, we can rely on experts' judgment to obtain at least 3-point estimates: a minimum value, a most likely or most probable value, and a maximum. With these values, we can construct probability distributions without the need for historical databases. Myth number 3, it is expensive and complicated. Over 30 years ago, Monte Carlo simulation software emerged for personal computers, significantly simplifying its application. Today, cloud-based applications like the one presented in this course are simple, intuitive, and accessible. These tools are designed to help project teams make decisions regarding durations and costs, removing the traditional barriers associated with complexity or expense. Therefore, Monte Carlo simulation is a powerful and accessible methodology with practical applications in risk management and decision-making for projects and businesses.